Okay, here is number 4. We have a box sliding down a ramp attached to a spring. Um, let's see if we can pull out the important information here. So we'll do that and that. So obviously we have the mass of the box, uncompressed spring. Okay, so that's telling us our initial spring energy row. It's got a velocity. Okay, it's sliding down. Constant friction force given, and we want to determine how far. Alright, so let's draw this out sort of as the two-star. So we have, that's not what I want. Let's see. We'll have a box. Wow, not much of a box right here. And then a little bit later, it comes down to here and stops. Okay. So we have some distance. Gosh, that's terrible. We have some distance it slides, x. Okay, that's going to be at an angle of 35 degrees. And the change in elevation we'll call h. Okay, so x and h are related by the angle of our incline. We also have a constant here and the given values for mass and speed. So conservation of energy again, our initial two states, we'll just call them 1 here. I'll write out all my terms this time so we don't forget anything. So I'll have gravitational plus spring plus kinetic plus work is equal to gravitational plus spring plus kinetic plus loss. Okay. Alright, so we'll set our datum at our lowest point. We don't know where that is, but everything can be based off of that lowest point. Alright, so that says our final gravitational is 0. Final kinetic is 0 because it comes to a stop, or it changes directions. It's maximum lowest point. The spring final is not 0, it's compressed. And energy loss, we do have friction force given here. Okay. No external forces other than the law, no work. It does have an initial kinetic energy. The spring is uncompressed at the start, so that becomes 0. And we do have a height. So we have 4 non-zero terms. Alright, so let's write these. This would be mgh1 plus 1/2 mv1 squared is equal to 1/2 k x squared. Energy loss is going to be calculated by the friction force times the distance it slides, which is x. Alright, so now what's left to do is plug in numbers and use the fact that we have a triangle here. So we have h is equal to x sine of 35. So we'll get everything in terms of x because that's what we want to solve for. Okay, so h is x35. So mass does not cancel out. It does not appear in these two terms, so I'm going to have to include it here. If we look at our units, if we're consistent, use mass, meters per second squared, and meters for the height. Okay, which we can do, and use meters per second for our velocity. Newtons per meter right here times meters squared will give us Newton meters, which is the consistent unit of energy. and the force in newtons times the distance in meters. So every term will have units of newton meters. I'm not going to write out all my units. 3, 9.81, x sine 35, plus 1/2, 3, initial velocity 8, and that's equal to 1/2, 300, x squared, plus 12 times x. All left to do is solve it. Alright, again, I'm doing this to sort of simulate the time it takes. Hopefully you can do this on your calculator just as quickly. Setting everything equal to 0. Times x times sine 35 plus 0.5 times 3 times 8 times 8. If you didn't see the other video, this calculator does not have exponentiation, so I just multiply twice. Alright, taking this over to the other side, minus 0.5 times 300 times x squared minus 12 times x. No implicit multiplication, you have to put the star in for everything. Okay, since x is my unknown, I don't have to specify it. And it gives me two answers, minus 0.78 and, oops, 0.816. Okay, your calculators ask you for an initial guess and only gives you the closest answer. This calculator by default gives me both answers. I obviously would choose the positive one. So 0.816, and that's going to be meters. Okay. So x equals 0.816 meters. Key points here were to relate the height and the distance, get the correct term for the friction loss, and just keep track of everything.